So down at the bottom of your paper, you will see, or sorry, down at the bottom of the screen, you'll see difference of squares. And that's the formula that you use. And basically, if you can look at something and it is something squared minus something squared, then we can use this formula. Well, as it's written, I see something squared, but is that written as something squared? No. Can you rewrite that as something squared? Yes. Okay, well, what about over here? Is 4 something that can be something squared? What about 16? Okay, so I'm going to do the second one with you, and you're going to go back and do the first one because the second one is more challenging. So for the second one, you have to look at each piece. So the first term, 4 is the same thing as what squared? 2 squared. So I'm going to take that whole term and it needs to be something squared. So I get 2x, and that's the same thing. Do you see that? Do you agree? We're going to do the same thing with the second part. I'm going to rewrite it as something squared. Okay, so 16 is the same thing as what squared? I'm writing really tiny. I'm going to write this big. Yes, it's the same thing as 4 squared. We already talked about that 4, if I have it to the 4th power, then, and I have squared on the outside, how many go on the inside? 2. So now I have something squared. There's my something, there's my something. So this acts as A, and this is like B. So when I write it, I'm going to have 2 parentheses, and I'm going to have A minus B and A plus B. The plus and the minus could be in either one. It doesn't really matter. And then you just put the stuff. 2x is written first, so it will be written first in each parentheses, or each parenthesis. The 4x squared is listed second, so you list it second. And that's it. That's all you do. So you're going to go back and you're going to do the first one. And as soon as you're done, you're going to go turn it in. And then we're going to get started on our stuff today. My goal is that we get through our stuff today so that you have time to do your homework. Oh, yeah. So as soon as you get done, get that turned in and yeah, scoot all that over. Thank you. New year, new you. Let's get started so that we can have time to do our homework. What did you guys get for the first one on the warm-up? X minus 7 and very good. Good job. So get that turned in. For today, I really don't think that you will need a calculator. If on the homework you think you might need a calculator, you can get one. Or if at any point during the lesson you feel like you need a calculator, fine, you can get one. I don't think you'll need one. So I'm not going to make everybody get up and go get a calculator. But what I do want is for everybody to put their phone away. So I think that you guys agree that you listen and pay attention better when your phone isn't in front of you distracting you. So I'm going to give you a moment to say goodbye to your phone and to put it away. So that means I don't want to see it. And if I see it out, it can go live on the phone wall. I don't like to police you guys, so just put your phone away. Oh, so when you go, put your name and the time you leave. Okay. Are we ready? So the first thing that we're going to do is review some stuff. So this is all review. So the first thing that we're going to review is factoring, and factoring specifically by GCF, and then we'll do grouping, we'll fast factor. And so I'm not going to spend a whole lot of time explaining this because we've already done it. So I've already taught it to you. And if you need to go find those videos, you can. So when you factor by GCF, so this is the first column, you're looking for the greatest common factor. You're looking for the biggest thing that you can pull out of both terms. So when you look at just the coefficient, so coefficient, it's the number in front of the variable. We have a 54 and we have a 2. What's the biggest number that we can pull out of both of them? 2. So when I pull it out, I'm actually dividing. So I'm going to pull out a 2 from each one, and then I have to look at the variables. So both terms have an A, so I can at least pull out an A. But what's the most amount that I could pull out of both of them? The most amount that I can pull out is A squared, or 2 of them. Does everybody see that? Michaela, do you see that? So it's the biggest amount I can pull out of both of them. Here I could pull out a 5, but here I cannot pull out a 5. The most I can pull out is a 2. So the most I can pull out of both of them is 2. What about the B's? Can I pull out a B from both of them? No, they have to both have a B, and they don't. So that's the biggest thing I can pull out. Anytime you pull out a GCF, you have to rewrite it out in front. It does not go away. It's still part of the problem. And then you evaluate each piece. So we have 54 divided by 2. What is that? 50 divided by 2 is what? 25. And then we have 4 divided by 2, which is 2. So we would have 25 and 2, so 27. And then when we look at the A's, one way that you can think about it, I'm going to write this kind of up at the top. We have a 5 on top and we have 2 on bottom. Every time one of them matches up, or it creates a pair, it turns into a 1. So what we're left with is 3 on top. Or you can subtract. So if I have 5, 5 is a bigger number, so you do 5 minus 2, and they go on top because 5 is bigger. For the second term, I'm subtracting. That's not going to change. I have 2 divided by 2. That is a 1. And then I have A squared over A squared. That's another thing that's exactly itself. So anything over itself is 1. And then I'm left with B to the 3rd power. Any questions over factoring with GCF? To check your work to make sure you did it correctly, you should always be able to distribute back in. You could take this and you could distribute it back in, and you should get what you started with. So you can always check yourself. Factor by grouping. So when you factor by grouping, hopefully this starts to jog your memory. You group. So we've got this pair and this pair of terms. And we look at each group. I probably should have written those on top. And we're going to individually pull out the GCF. So when I look at my first term, when I look at the first grouping, what's the biggest that I can pull out of both of those terms? Yeah, I can definitely pull out an 8 and an x squared. So I pull it out and I write it in the front. And then I write down what I have left. 8 divided by 8 is 1. If I have 3 and I'm taking away 2, then I have x. 24 divided by 8, what's that? 3x squared over x squared. It's over itself, so it's just 1. For my second grouping, what's the biggest thing that I can pull out of? So when we do factor by grouping, remember that our goal is to get two parentheses that are exactly the same. What I have in parentheses is x minus 3. I want another x minus 3 or else I'm not doing it correctly. So when I look over here, the only way that this can be a minus is if I divide out a negative. So I have to divide out a negative, whatever it is. You can also tell because the signs are not the same. So this is a plus and then a minus, and this is a minus and then a plus. So the only way you can reverse those signs is to factor out a negative. So I'm going to factor out a negative, and then what's the biggest thing that you can pull out of a 2 and a 6? 2. So I pull the 2 out and I put it in front. Negative 2 over negative 2, that is a 1, so you just have an x. 6 divided by negative 2 is going to be a negative 3. Yay! Goal was to get two parentheses that are exactly the same, and I did. So that is a new GCF. I write it out in front one time, and then I write down the things that I have left. So the things I have left are that and that. Holy moly. I forgot, but that's okay. Sometimes we'll do this. Always want to double check and look and see, is that as simplified as I can get? So when I look at x minus 3, can that be reduced anymore by a GCF? No. What about here? Is there anything that's in common? 8 and 2, can I pull out a GCF there? What? I can pull a 2 out of both of those. So I have one more step. What should I have done at the very beginning of the problem? Factored out a 2 from the very beginning of the problem. I'm rusty too. So we can pull out a 2 and it'll go out into the front of the whole problem. And I write down what I have left. So I have a 8 divided by 2. That'll give us a 4. And then 2 divided by 2, that gives us a 1. So when we learned factoring in the beginning, we really didn't come across this much because I didn't give you very many problems like this. But one thing you've got to double check for is perfect squares. So that's why we did that warm up. And when you look here, anytime you have something squared minus something squared, you can factor again, which you can actually do here. 4 is the same thing as what squared? 2 squared. 1 is the same thing as what squared? 1 squared. So this is technically 2x squared minus 1 squared. So I can factor, continue factoring. So I get x minus 3, and then I write my 2 parentheses, and I'll have 1 plus and 1 minus. Doesn't matter which order. And I have to write the first thing first, second thing second. Now I'm finished. Chances are, if you are doing a quiz or a test and there's a multiple choice question and it's asking you to factor, if you go and you look at your answer choices and you come across one of them and it seems to have more terms than you thought you were going to have, like you get to here, but answer choices have extra ones, it's probably because you can continue factoring. And remember, it doesn't matter if it's plus. Plus doesn't do this, only a difference of 2 squares. Fast factoring, this time we're not going to forget. When I'm looking here, they're all even numbers. That means we can divide by what? 2. So let's do that first. And plus, the title says fast factor, and A has to be equal to 1. A is equal to 2, so I couldn't even fast factor if I wanted to. So I'm going to first factor out the GCF, which is a 2. Anytime you factor something out, factor means put in front. Y'all know that factor is just the opposite of multiply. So factor is a fancy way to say divide. That's all we're doing. So factoring is just the opposite of multiplying. So we pull out the 2 and we write down what we have left. 2 divided by 2 is 1. So x squared, 16 divided by 2, that's 8. 30 divided by 2, 15. Fast factoring. It's called fast factoring because it's fast. Anytime you have A is equal to 1, it's fast, it's easy. So we set it up where we've got 2 factors. I'm going to have an x and an x because that's the way I would get x squared. And all you're thinking of, and so fast factoring, A is always equal to 1. So it's 1 times the last number, which is 15. So we have factors of 15. There's not a whole lot of them. We've got 1 and 15, 3 and 5. Some of you don't have to make the factor tree or the factor pairs, and some of you do. If you need to, do it. If you don't, then that's fine too. You can do these in your head. So we're looking for the pair that we can put together to give us 8. 3 and 5 works. So when I put them together, I put 3 and 5. Doesn't matter which one you put in there. And now to decide the signs, and this only works with fast factoring. So when you're splitting the middle, you have to do a little different. But when you're fast factoring, you look at the middle term. The middle term is negative. The bigger number has to be negative. So we'll make it -5. And from -5, if I have -5, would I add or subtract to get to -8? Subtract. I'd have to get more negative. So I'd have to subtract. Who was ready for math at before noon today? Me neither. Me neither. Good news is we're not doing this one, so you can cross it off. And you can go cross off number 1 on the homework. We met yesterday and decided we're not going to do those. We already did them last semester, so let's not do them again. How about that? So question number 4 is a difference of squares. So this will be the 4th time that we've done a difference of perfect squares today. This is a really important one. We need to be able to identify these and we need to be able to kind of get them quick. So this is a difference of perfect squares. So anytime you see those perfect square numbers, we've got 9 and 16, 25, 36, 64, 49, 100. Anytime you see those, it should ring a bell that maybe I need to rewrite it as something squared. So for this one, I have x squared. And then how can I rewrite 16 so that it's something squared? Bless you. 4 squared. All right. So on your paper, I want you guys to write down that pattern. Remember, it's going to be first thing first. One of them is going to be plus, one of them is going to be minus. You set up the 2 parentheses. I want you to see if you can do this one. Again, this is the 4th time we've done this today. So don't try it on your own, but don't look up until you've tried it. Did anybody get the same thing, but your plus and minus were switched? It's fine. It's the same exact thing. Okay, remember that the one, whichever one's plus, whichever one is minus, it doesn't really matter. In this case, because you could move them. The order doesn't matter. Okay, so far we're probably not experts at these. Hopefully it kind of is like, yeah, I kind of remember doing those. I couldn't take a quiz on it, but I'm kind of starting to remember. The whole front page of your homework is practicing factoring. So we're going to practice factoring. The last type that we're going to talk about is splitting the middle. There's not a whole lot of these. So this is when the leading term is not equal to 1. So as I'm looking through here, let's see. Question 6. I'm looking at your homework, so just giving you hints. Question number 6. The leading coefficient isn't equal to 1, but what can you do first? For question number 6 on the homework. Yeah, there's a GCF. What is it? 2. Yeah, you can factor out a 2. So then you can fast factor. Question number 7. It will end up that you got to bring the 3 over. You got to subtract 3. And then you have a leading coefficient of 2. And you know what? 2 and 3, you can't factor out a 3. So number 7, you will have to factor by splitting the middle. That's what we're doing. Anything that has 4 terms, you're going to factor by grouping. Question 10, that one, looking at just the numbers, I have 2, 12, and 14. Do you have a GCF? What is it? It's a 2. But this one is also a little tricky, and we haven't done a whole lot of practice with this, with a trinomial, something with 3 terms. But you can also factor out, each one of those has an x in it, so you can factor out a 2x for that one. So anyways, on the front side of the paper, there's only one of them that has factor by splitting the middle. It's to me the longest one. It's the one that I enjoy doing the least because it takes the most time. So factor by splitting the middle. This happens because a is not equal to 1. So that leading term, it's not a 1. Okay, so what do we do when the leading term is not 1? So it's a combination of, we're going to do grouping and fast factoring kind of together, sort of. So first thing that we got to do is we have to look at a times c. So this is 2 times negative 12. What is that? Okay, hold on just a second. Hello? I did. I was just going to see, I have an appointment at 4:30. I just wanted to see if I could come at like 4:40 or 4:45. I don't think it has to be 5, but I mean, I could come. Yeah, that would work. Okay. Okay, we can make that work. No, 5 is fine. Thank you. Bye. Okay, thanks. Okay, so now we're going to look at factors of 24. And for the most part, yeah, same thing on question number 7. You'll end up with 2 times negative 3. It's not going to be a big number, so it's not going to be like this list of 45 factor pairs that you're going to come up with. So when I list my factors, I usually just start with 1, 1, 2, 3, 4, see what can go into whatever the number is. So factors of 24, we can start with 1 and 24, 2 and 12, 3 and 8, 4 and 6. Can y'all think of any more? I think that that's it. And then they reverse, so you don't have to write those. So the next thing that we're doing is we're looking for the factor pair that can make negative 5. So it has to be, let's see, to make a negative, it has to make negative 24 when we multiply. So one of them is going to be negative and one is going to be positive. That's the only way you can multiply and get a negative. but we also have to be able to put them together to make a -5. So you got to look at two numbers. 3 and 8 can work. And if you use 3 and 8, if we want it to equal -5, the bigger number has to be negative. So it's got to be a -8. And if I have -8 and I want -5, I would have to add 3, which also makes sense because if I have -8 times 3 will give you -24. If they were both negative, then this would end up with a positive. Now what you do is you split the middle. So all I'm doing is rewriting -5 to look like 3 and then -8 because it's the same thing. And then everything else is just rewritten the way it is. All I did was split the middle term. And anytime you have 4 terms, what can you do when you factor? Grouping. So when you factor by grouping, remember that your goal is to get 2 parentheses that are exactly the same. If when you're if when you're factor by grouping, you notice that you don't come up with 2 things that are the same, maybe you split the middle wrong. But you should come up with two factors that are 2 sets of parentheses that are exactly the same. And I will tell you that if you put the -8 first and then the +3, and your friend had it reversed, that's okay. You're going to get the duplicate parentheses will be different than your friend, but your ending answer will be the same. So now I'm going to look at my groups. 4 terms means I will factor by grouping. In my first group, what's the biggest thing that I can pull out? What's my GCF? Yeah, just an X. So I factor it out and I put it in front. I'm left with a 2x plus 3. So if I did this correctly, I should end up with another 2x plus 3. As I'm looking, both of these are negative. So I'm not going to end up with a +3 unless I definitely have to pull out a negative. So whatever I divide by, it will have to be a negative something. And then what's the GCF of 8x and 12? -4. Yep, I think that's all because I can't pull out an x. So I'll have a -4, and then I write down what I have left. -8 divided by -4, so that will be a +2. Negative by negative will be another +12 divided by 4 is 3. Good job, because we wanted 2 sets of parentheses that were exactly the same. So we've got our 2 identical parentheses. That's our new GCF. We're going to write it one time in the front. And then you write down what you have left. So x minus 4. And then I'm going to double check. No more GCF out of that one. This one, if it was an x squared, it would be a difference of perfect squares, but it's not. So that is completely factored. Are y'all tired of factoring already? Yes, factoring is exhausting. So we're going to take a deep breath and I will tell you an announcement about the bathroom pass. So number 1, it is the bathroom pass. So if you're using it, go to the bathroom. So where are you going? You should be going to the bathroom. Every once in a while, y'all need to go somewhere else. You need to go to the library. You need to go talk to a teacher. You need to go to the office really quick. You need to go whatever it is. Those things, by and large, are fine with me, but don't take the bathroom pass, because the bathroom pass is for somebody that wants to run across the hall and go to the bathroom. And so what I have found is that a lot of times some of y'all take it and then you're wandering around, or you had to do something that's going to take longer than go to the bathroom. So everybody's waiting on you. So don't take the pass unless you're going to the bathroom. So if you need to want to do one of those other things, come and ask me and I'll write you a sticky note pass. So what you're also going to do is you're going to start putting your name and the time. So this helps me find the pass. I know that nobody wants to steal the pass. Who wants a bathroom pass? That's weird. But sometimes we can't find it, or people are waiting because they want to go, and so forgot that it's in their pocket. So if so-and-so forgot it's in their pocket, and they look up here and they see, oh, Jacob took it and he went to the restroom, but he's sitting right here, then you know who to ask for the pass. So that's why we're putting our name and with the time. So again, if the time was an hour ago, chances are they're probably back. Then for the pass. So it says restroom, you don't have to change that in anything, you can leave it as restroom. And so just make sure you jot down your name and the time that you left. It doesn't have to be exact, just write down the time. So if you take the pass, please just write it down. Any questions on that? Okay, maybe that will also help some of you that take the pass and you're gone forever, to know that we only have one pass, and so people are waiting on you. Now we're getting to the real stuff. So the factoring isn't actually anything new. It wasn't really teaching you new stuff. Today, we are going to go over exponent rules. That's the actual lesson of the day. Exponent rules. So what I find most often is that exponent rules are taught at the end of the year, and they're really abbreviated and nobody ever remembers them. So even though you're supposed to have seen them before, most people get to me and they act like they've never seen them or done anything with them, which sometimes is true because, like I said, they're taught at the end of the year, and a lot of times it's abbreviated, and for you guys, it was COVID, so. Manual. Can you put your phone on the wall? Okay, so exponents, there are rules. So we're going to jot down the rules and we're going to practice them as we go. Some of these we've been doing, and so some of them we've even done today. And so some of them will be a refresher because we use them naturally in math. Others we don't use super often. The first one, anything to the 0 power is, does anybody know? Nope. 1. It's kind of weird, but yeah. Anything to the 0 power is 1. 1. So what is 14 to the 0 power? 1. What's -5 to the 0 power? 1. What's 152.3 to the 0 power? 1. What is something really ugly in parentheses, all raised to the 0 power? 1. Anything raised to the 0 power, you don't need a calculator for it. It will always be 1. It doesn't matter what it is. Anything to the 0 power is 1. All day, every day. It just is. Negative exponents. Every once in a while, you get a negative exponent. Negative exponents can be fixed. So that means that if it's a negative exponent in the top, we can fix it because we'll rewrite it in the numerator. So if it's in the, if it's in the numerator, we rewrite it in the denominator and it becomes positive. Or if it's in the denominator, we can write it in the numerator and then it will become positive. So it's easier to show you. The first example, see how this little exponent is negative? What's the exponent attached to? What's the base for that exponent? X, right? So it's attached to the X. It's not attached to the 2, is it? If it would have to be in parentheses for it to also attach to the 2. So it is only applied to the X. So the 2 has nothing to do with it. It will stay in the numerator. All I'm going to do is rewrite the base in the exponent, and now the exponent is positive. The second example, see how there's a negative exponent? It's in the denominator. So what we're going to do is we're going to rewrite it in the numerator. And so again, for this one, the negative exponent is only attached to the x. It's not attached to the 2. It would have to have parentheses. So I'm going to put, and does the negative exponent have anything to do with that 1? No, so the 1 can stay there. So up on top, I'm now going to write x, and it will be a positive 3. I didn't do anything with the 2, so it stays where it is. So all I'm doing is moving the base and the exponent. If it's negative, you can move it to the top. And if it's in the denominator, or if it's in the numerator, you can bring it to the denominator. Any questions on how you can fix a negative exponent? Okay, we'll get better with practice. Coefficients. So remember, the coefficient's just the number that's out in front. So when you're adding or subtracting coefficients, you are going to do nothing to the exponents. The exponents stay the same. So stay the same means, okay, I've got 4x squared, and then I'm taking away 2x squared. So how many x squareds do I have left? I have 4 of them, and I'm taking 2 of them away. I have 2x squares left. This is another way of calling like combined like terms. You don't do anything with the exponent. It was squared, it stays squared. So when the exponent, sorry, when the bases, coefficients, when the coefficients are adding or subtracting, you don't do anything to the exponent. It will stay the same. You just add or subtract the coefficients. When you're multiplying the coefficients, you're going to add or subtract the exponents. The exponents, sorry, you add them. When you multiply, you add. So here I have a 5 and a negative 3. That's multiplying because they're written like that. You can see that you're multiplying. So if you multiply, you're going to add the exponents. So 5 times negative 3, what is that? What's 5 times negative 3? Negative 15. And then for the x's, if you multiply the bases, sorry, if you multiply the coefficients, you add exponents. So I have 3 and I will add 2. So how many do I have? 5. If you divide, see, if you multiply, you add. If you divide, what do you think you do? Subtract. And I put on there, technically, it doesn't really matter. You can subtract to the top or you can subtract to the bottom. But if you subtract to the bigger one, if you subtract to the bigger one, then you will end up with a positive exponent. Okay, if you just always subtract to the top or the numerator, then sometimes you end up with a negative exponent and you got to fix it in the end. So one little trick is that if you always just subtract towards the bigger one, then you end up with positive exponents. And I'll show you what that means. So these coefficients, I have a 4 and I have a 2. They're written like division, so you're dividing. What is 4 divided by 2? 2, and so it would go on top. Now I'm looking at the exponents. I have a 2 and I have a 3. Which one is bigger? The 3. So my variables are going to go, the x is going to go on the bottom because the 3 is bigger. And if I have 3 and I take 2 away, how many do I have? 1. So I have 1 on the bottom. Do I have to write to the first power? No. You can, you don't have to. What would happen otherwise is that if you put the x's on the top, then you have 2 minus 3, so you would end up with negative 1, and then you would have to rewrite it in the bottom anyways. So if you just subtract towards the bigger one, you'll always end up with positive exponents. For this one, we have a 3 and a 2 that can definitely reduce. What is a 3 and a 6? What does that reduce to? 3 goes into 6 2 times, but the 6 is bigger, so it needs to go on the bottom. It becomes 1/2. And then for the x's, I have a 5 and I have a 3. 5 is bigger, so I'm going to write the x's on top. If I have 5 and I take 3 away, how many do I have? 2. You could write it like that. It's also the same thing as just saying x squared over 2. Either one is okay. You don't have to write the wrong one in front, but if you do, it's not wrong. The next exponent rule we're going to talk about is when the coefficients are raised to a power. So here I have 5 and all of this stuff is raised to a power. So this is an example where the exponent of 2, it also applies to the 5. Now the 3 only applies to the x, but the 2 applies to both of them. So anytime you are raised to a power, you will multiply exponents. So this 2 on the outside, it's going to distribute into both of these pieces. So you end up with 5 squared and then x to the 3 times 2 squared. Now we can clean it up. What is 5 squared? 25. What's 3 times 2? 6. Sometimes you'll see it written as 5 squared and then x to the 6th power. Sometimes you'll see it as 25 x to the 6th power. They're the same. So what I want us to do, because does this seem like kind of a lot to remember right here? Like, what do you do with the exponents? Here's how I remember. You have to look at the relationship. So let's think about this. Like the biggest operation that you can do to something in these cases would be to raise something to a power, right? So if we're thinking about like operations, like the lowest thing you could do is like nothing. And then like the next biggest operation is like adding or subtracting. And then more than that would be multiplying and dividing. And then more than that would be raising it to a power. So shake your head if you see what I meant by that when I was saying that. It's like getting to be a bigger operation. So if we look at the relationship of these operations, that's the one that's like the biggest one, right? So those operations that I just said, I'll jot them down. So I said you first could do nothing. Then you could add or subtract. Then if you wanted to get a bigger operation, you could multiply or divide. If you wanted a bigger operation, you could raise something to a power. Oh man, I put it where y'all can't see it. Okay, so you could add or subtract, you could multiply or divide, you could raise something to a power. Do you guys see, does that make a logical order for you? So let's look at these. So if you are raising the coefficients, you're raising it to a power, you multiply. These are kind of together. If you're dividing, you subtract. If you multiply, you add. If you add or subtract, you do nothing. The exponents, they stay the same. So basically, whatever operation you're doing, you're going to do one less to the exponents. So if you're raising something to a power, you're going to multiply. If you're multiplying, you add. If you're dividing, you subtract. And if you're here, there's no operation in front of that. So you do nothing to the exponents. So that is how I remember. You do one less operation. Now let's practice. On the back, it says to simplify. So it says simplify and rewrite with it without any grouping symbols or negative exponents. Okay, grouping symbols are like parentheses. For this one, you cannot take care of a negative exponent. Like, how do you know what something to a negative power is? We don't know how to do that. So the first thing you have to do is make that not a negative power. So how can I rewrite 5 to the negative 2 power and make it a positive power? Go look at your notes. It's on the front. We're going to rewrite it in the bottom or in the denominator. So first we can rewrite it as, you have to have a placeholder there. If you rewrite that in the bottom, you can't leave nothing in the top. So I rewrite so that I have a positive exponent. Now that I have a positive exponent, can you tell me what 5 squared is, or 5 times 5? 25, easy. So this becomes 1 over 25. So what is 5 to the negative 2 power? It is 1/25. Tiny little number. The next one is 3 to the 4th power. I told you you didn't need calculators. We might need one for this, but let's try and do it without. So that is the same thing as 3 4 times. So it's 3 times 3 times 3 times 3. Okay, what's 3 times 3? 9. I know you know it. And 3 times 3 again is also 9. Well, then we got to do 9 times 9. What's 9 times 9? 81. We did it, and we didn't even need a calculator. Good for us. The next one, -4 to the 3rd power. So this is where you have to be careful. You have to know this. That when you have a negative and a negative, it becomes a positive. Everybody messes up on these. So if you're using a calculator for these, you've got to be careful because everybody types them in and they type it in as -4 to the 3rd power, and then they get the wrong answer because unless you put parentheses, the calculator will not do it correctly for you. So you have to know that that's -4 times -4 times -4. It's a -4 3 times. That's what exponents are. And we can do this the same way. You guys are smarter than you think. So -4 times -4, negative times a negative, that will become a positive. 4 times 4 is what? 16. All right. Now we have 16 times -4. That seems like a lot, but guess what? We can do it. So I know that it's a -4. So my answer, it's going to be a negative because it's going to be a positive times a negative. And you can just multiply it out. Remember how to do this? We've got 4 times 6. What's 4 times 6? 24. So we put the 4 here and then the 2 up here. And then we've got 4 times 1 is 4, 5, 6. So we end up with -64. So basically, anytime you have an odd amount of negatives, you're always going to end up with a negative number. An even amount of negatives will always turn into a positive. Ooh, like this one. See how we've got a negative and we have an even amount of them? Your answer is going to be positive. But let's write it out anyways. So looky here. This is kind of interesting, right? Because we have a -2 as an exponent. But how do I write that in the bottom? How does this even work? So I'm going to show you step by step, but then I'm going to tell you in the end that it's really easy. So don't write anything down. Just wait a second because I want you to see what I'm doing. And then you don't do it the long way. You can do it the short way. So what this means is that I have to distribute in that exponent to both pieces. And when I do that, and the negative's still there, so I end up with 1 to the -2 power over 3 to the -2 power. Because all I did was distribute in the exponent to both pieces. When you do that, how do you fix a negative exponent? You just put it in the bottom, or if it's in the bottom, you put it in the top, right? So the one that's in the top, it's going to go to the bottom. The one that's in the bottom is going to go to the top. So what this is going to turn into, it's still a negative, is 3 squared over 1 squared. So there is a trick when you have a negative exponent and it's a fraction inside. All you have to do is flip the fraction, because that's what ends up happening. So anytime you have a fraction, you don't have to do that middle step. You can just distribute in the 2, but you have to switch the 1 and the 3. And you get the same thing. But again, if you forget, you can always just distribute it into both pieces and then fix it. From here, we can evaluate this. So you can put the negative with either the top or the bottom. It doesn't matter. There's only one negative sign, so it can only go to one of them. Let's put it with the top. So if you put it with the top, you have -3 2 times. So what's -3 times -3? What? +9. What is 1 times 1? 1. And that's the same thing as just 9. Most of these exponent problems are not difficult. You just got to be careful. Most of them are not difficult at all. We just have to be careful. Okay. The next ones that we are going to do, these are just adding, subtracting. So all it is really combining like terms. You got to put like terms together. So you can remember that here, when you're adding or subtracting the coefficients, the exponents are going to stay the same. So you just got to put x squared with x squared. You got to put x's with x's, x cubed with x cubed. If something doesn't match up, that's fine. It will stay the same. So what I like to do is set it up like a first grade math problem. You leave what you have first as it is. The second thing, just go line up each of the pieces so that you can add vertically. So here, I'm going to leave that as it is. I'm going to put this over there. So first thing I have is a 6x. I need to match it up with the 3 because it is also an x. And it's a +6. So this is like a positive distributed to all of them. Is multiplying anything by positive going to change it? No, so they're all staying the same. So I add 6x. So I took care of that one. Then I have a -8. Ooh, does this have any terms over here that don't have a variable? No, so I'm just going to have to add 8 in its own column because there's nothing to add to it. And then the 2x squared, there is an x squared, or there's a x squared there, so I have to line them up. Oh, why did I put my up +8? I don't know. I shouldn't have. I don't know why I wrote +8. It was -8, so it stays -8. So plus 2x squared. So I lined them up. I put the x's with the x's, the x squared with x squared, and then I had something by itself, that's fine. So I add straight down. So if I have 6 and 3, I have 9x. If I have 2, and I usually start with +1. If I have 2 and I take 5 away, then how much do I have? -3, and I don't do anything with the exponents. And then the -8, it's like 0 minus 8, so I have -8. It doesn't tell you in the directions, but I am going to tell you that what I would like for your answers to look like is that they are in standard form. Standard form just means you put the biggest exponent first. In this case, 2 is the biggest exponent. So I'm just going to rewrite it so that it's an exponent of 2, and then an exponent of 1, and then an exponent of none. So when I rewrite this, all I did was rearrange them so that the x squared term is first. That is standard form. And one thing that you can do sometimes when you're looking at these is you can even make placeholders. Ooh, this next one's kind of ugly because we've got X's and Y's. Oh, okay. Well, here's the thing about those. So another way that you can do these is you can set up like placeholders. When I do these, the biggest exponent I see is a 3. So we've got x to the third power and we have a y to the third power. So those are going to be the first exponents that we write. Usually, if you've got 2 variables, then you write them in like alphabetical order. So x comes before y. So I'll write the x's first. So all I'm doing is setting myself up some placeholders. So I'll have x cubed, and then I'll have y cubed. And then the next thing that would come would be x or y squared. Do I have any squared terms? No, so I don't have to make a placeholder for that. And then I do have x's and y's. So I have x's and I have y's, and then I have constants. So a constant I'm just going to put as a c. So I'm going to have placeholders like this. And I can go write anything that has that base to it. Anything that has that variable, I can write it in that column. So this is just a different way to kind of do these. So I'm going to go write anything that is an x to the third power in that column. So I have minus 5x to the third. That's it, actually. And so then my plus 6y plus 2x. The second one, you have to be careful because see, there's a negative. So that means everything in here gets multiplied by a negative. So everything is going to change sign. So they actually all become negatives, or the sign is opposite now. So I get a negative 5, a negative 3x, a minus 6y cubed, and then a minus 3. I only have 2 things that are going to get put together. But when I am done, everything will already be in standard form. So if you don't combine it with anything, it just drops down. I do need to put the 2 and the 3 together. So if I have 2 and I take 3 away, how many do I have? If I have 2 and I take 3 away, how many do I have? Negative 1. I have minus 5 or negative 5, and I'm getting 3 more negative. So now I'm already in standard form. More often than not, you don't have mixed variables. Most of the time, you do not. Most of the time, they're always the same. All right, so I'm going to have you do C and D on your own. Ooh, I see a 0 exponent. What's that become? What's 5 times 1? 5. So this whole term, the x kind of disappears. It's just a 5. So again, I'm going to do these. I want you to do these, and then you're going to look up and you're going to check your answer. So I'm also going to do these. You do them, and we're going to check our answers. The hardest part about combining like terms or adding or subtracting is just matching up the like terms. Is this what y'all got? Hopefully this is what you got, or if you got something different, you're like, oh, I see what I did wrong. How'd you do? Again, the hardest part about adding and subtracting is just lining up who goes with who. And sometimes it's tricky when you have the negative out in front. You got to make sure that you change the sign of everything. It doesn't mean that everything inside becomes negative, because this one was a negative, so it becomes a positive. It just becomes the opposite sign. Okie dokie, we will move on. So take a deep breath. And I want to remind you, not remind you because I haven't ever told you. I want to tell you that if you come to tutorials, so tutorials doesn't mean that you have to be coming necessarily before or after school. Some of you guys come during an off period, something. Anytime you come and it's not your class period, then I want to make sure you get credit for that. And there's a variety of reasons why. It could be because I want to make sure if your parents ask me, is so-and-so coming to tutorials, I want to give you credit for it. I want to make sure that, let's say in 3 weeks, you find out that you owe makeup hours. Well, you can come back to me and you can say, hey, miss, remember when I came to tutorials? I'm probably going to say, no, I don't remember. But if I have a log, then I can say, oh yeah, you did come that day. I don't mind giving you credit for that. So it's not anything fancy. I don't do anything with it. It's just so that I can remember. So you get credit if you come. So it's just for yourself. So if you come anytime, even if it's coming to do something really simple and you're here for 10 minutes, make sure that you tell me, oh, let me sign the tutorial log, just so that you have credit of being here. If a coach asks me, if whatever, I want to make sure that I have credit for you being here. So I also put a note here, make sure if you come to tutorials, ask me to sign the log. I put it up there. There's 2 more notes and 1 over there. So there's notes all over to remind you. Many of you don't ever have to come to tutorials, but if you do, get credit. Some of you also sometimes will come. I have you guys during lunch. So if you come in early for lunch because you're studying for the test we're about to take, get credit for it. We're almost done. I know these problems are exhausting and nobody wants to be here anyways. These say simplify, rewrite without any grouping symbols or negative exponents. I think multiplying is easier than adding or subtracting, but let's see. So when we do these, you got to first look at what you're doing to the coefficients. We're multiplying. So when you multiply, what are you going to do with the exponents? If you don't remember, flip it over. It's one less, one less. So yes, we will add. So let's multiply the coefficients. So I have 3 times -4. What's 3 times -4? -12. And so then I have the x's. So I multiplied bases. One less operation will be adding. So I have 7 plus 2. That's it. Yes, that's what I was saying. Multiplying and dividing is typically easier, faster. For this one, I'm raising something to a power. So when I raise something to a power, what do you do with the exponents? If you don't remember, flip it over. It's one less operation. You multiply. So what I'm doing is I'm taking this 3 and I have to distribute it into every single thing, even the 5 in front. So the 5, it will be -5 raised to the 3rd power. And then I have x. So if I'm raising something to a power, I will multiply. So I have 3 times 3. And then y, oh, darn. So this is a -3. We can fix that. Times 3. And then I have a z, 2 times 3. Now what we're going to do is we're going to fix them, or we're going to multiply them. So the first thing I have, it's going to be a negative times a negative times a negative. So it's a negative times a negative times a negative. It's an odd amount of negatives. So is it going to be positive or negative? Danny knows. What about everybody else? And if you don't remember, you can also write them out. It'll be a negative times a negative times a negative. Every time you have 2, it will become a positive. So now I have one big positive times a negative. So it will equal a negative. So the -5 to the 3rd power, that will be a negative. So we've got 5 times 5 times 5. What's 5 times 5? 25. And then we've got that 5 times. Think about 5 quarters. How much is that? 125. So we've got -125. Now we can look at the x's. So it's x 3 times 3. What's that? 9. This one's going to turn out to be a negative, right? How do we fix a negative exponent? Write it in the opposite. If it's in the top, write it in the bottom. So we're going to have a fraction. So 3 times 3 again is 9, but it would be negative in the top. We'll make it positive by putting it in the bottom. And then for the z, it's 2 times 3. What's 2 times 3? 6. The next one. This one should be easy. We've got a y in the top and the bottom, or in the numerator and denominator. We've also got a z. So all we're going to do is match them up. When you divide, what do you do with the exponents? When you divide, you will subtract, and you subtract towards the bigger number. So when I look at these, I have a 2 and I have a 1, so 2 is bigger. So y is going to end up on top. And then for the z's, I have a 3 and a 5. 5 is bigger, so the z is going to end up on bottom. So on the top, I end up with 2 minus 1. What's 2 minus 1? Just 1. And for the bottom, what's 5 minus 3? That's it. So that's the basic operation. And then the next one is just more. So we're going to take the exponent of 2 and you've got to distribute it into every little piece on the top and on the bottom. And what happens when you have something to a power? What do? One less operation of raising to a power would be multiplying. So you will multiply as these go in. So every exponent is times 2. I get to the 14th power. And to the negative 6th power. And to do this problem, you could have either simplified the stuff on the inside and then raised it to a power, or you raise everything to a power and then simplify. It doesn't matter. 6 times 6 is 36. 4 times 4 is 16. When I look at the m's, I have a 14 and I have a negative 2 for the exponents. 14 is bigger, so it will go on top. 14, this is a tricky one. So it's 14 minus negative 2. 14 minus negative 2. So you're actually adding. So 14 plus 2 is a 16. And then for these, which one is bigger, negative 6 or negative 10? Think of a number line. Negative 10 is further away from 0. So negative 6 is actually bigger. So we're going to put the n on top as well. And so this is negative 6 minus negative 10, which is actually plus 10. So 10 minus 6 and leaves me with a positive 4. Can 36 over 16, can that reduce? They're both even, so I know they can at least reduce by 2. But is there a bigger number that can go into 36 and 16? There's a bigger number than 2. Three doesn't go into both of them. 6 doesn't go into both of them. What number goes into both 36 and 16? 4. So 36 goes into, 4 goes into 36 9 times. 4 goes into 16 4 times. We're not going to do the on your own ones because we're running out of time. So what I do want to show you are these two. When you see one like this, you need to rewrite it. And you're going to rewrite it like we've been doing when we factor by grouping. So you're rewriting it with the denominator under every single term. So I'll show you what I mean. And then you put whatever sign you see in between. So all I did was rewrite that so that the 8x squared y squared was under every single term, because that's what it's actually asking you. It's saying, take all this stuff and divide it all by that. So rewrite it so that they're all dividing. I think it's easier to do this problem that way. So this is just like we did at the very beginning. We're going to take and we're going to divide each piece. We've got 24 divided by 8. 24 divided by 8 is 3. And then when I look at the x's, I have x squared over x squared. Anything over itself becomes 1. Now I have y's and they're being divided. 3 is bigger, so I get 3 minus 2. So I just get y to the first power. That's my first term. My second term, I have 32 divided by 8. So what is that? What's 32 divided by 8? 4. All right, then I have x's and I have y's. It looks like both of them are bigger on the top, so they will stay on the top. So I get 5 minus 2. So I have 3 x's. And then for the y's, I have 6, 5, 4. For my last term, I have 16 divided by 8. What is that? 2. X squared over x squared is just 1. And then I have y to the 5th minus 2, so 5, 4, 3. That is my answer. So this one looks scary, but all you have to do is write it as 3 individual terms. The very last type of problem, it's multiplying. You're going to multiply and you're going to use a box. So when I make a box and they aren't even, so this has 2 terms and this one has 3, it doesn't matter which one you put where, but I usually do the one with 3 terms along the top. I don't know why, it's just what I do. So I have x squared plus 3x plus 5. And then down the side, I have x minus 4. Y'all have done this before. It's just multiplying with a box. You don't have to multiply with a box, but you're going to make mistakes if you don't. So please use a box. So we just multiply the stuff inside. I'm not going to say it as I do it because I don't want to mess y'all up. For these, just remember that when you multiply, if you're multiplying, you add exponents. So this is a 1 and a 2, so it becomes a 3 for the exponents. If the things that you put along the top are in standard form, you will still have like terms that go diagonally in the peanut, and you can combine the like terms as you rewrite it. The first, I guess, 9 problems, since I marked one off of your homework, are factoring problems, and the back 11 through 26 are all exponent stuff. But before you put everything away, look at question number 3, because there is a typo. You need to fix it. That you need to fix. And remember, question number 1, you mark off. So question number 3, it was written with 2 equal signs. My bad. It should be plus for plus 63.